You want a fruit snack for good measure?
What is it?
An orange fruit snack?
Is it real orange?
I think so.
It's a carrot.
Oh, it's shaped like a carrot. It's good for your eyes.
This is like a candy. Give me
Oh,
candy.
it
gummy
is
or something.
I said a fruit snack.
I thought it was like real
What were you
fruit.
expecting?
No? All right, thanks. Nonetheless, thanks.
Yeah.
I think we're good to go, Jen. Whenever you want.
Okay. Okay, welcome, Throngs, to our weather discussion today. We have, I feel like Charles Barkley at the NCAA broadcast a couple of years ago, when they had the Homer channel, the so-called Homer channel, when if UNC Asheville was playing, you could get UNC Asheville announcers on the broadcast and TV. Anyway, that inspired a lot of complaints to CBS that how come this broadcast is so biased if you're watching from another school? And Barkley couldn't contain himself. He said, "Y'all fools aren't listening. We have a Homer channel." So today I'm looking out at this crowd, which numbers in the sevens, and it's because y'all fools in the senior class are on the road to Iowa looking for some interesting weather. So I hope they're being careful and circumspect. But I also hope they have success, because next week, if they do, they'll have plenty to tell us about how that chase went out. But what a week it's been. I mean, a week ago today, we were talking about 1 or 2 inches of snow Friday night into Saturday morning, with the heavy snow on a line from like Rockford to Des Moines or something like that. And although I do think we did talk as a group about the possibility that a little shift to the north would make a whole different story, and that's what happened. We ended up with 12.1 inches of snow on Saturday here last week, which is the snowiest single March day in Madison's history. That goes back, to 1870. So it recorded history for weather anyway. And that put us at 25.3 inches for the month of March. It's been a snowy month of March. Their all-time record was 25.4 in 1959. And there was, I'll point out here on the satellite as we watch it in a minute, we had a couple of chances to add that extra 1/10 of an inch. Wednesday morning was one chance, and then it looks like it'll be hours late, past midnight on April 1st, when we get plenty of snow to get over that hump, but it won't count. So we're going to finish second, but it'll be the snowiest March since 1959, which is unbelievable. So,
Have you looked at Ed's things at all? The climatology things?
No, we're at 70 inches for the year, I think.
There's the snow.
Yeah, so we're right at 70. So we're right at 70, which is just amazing. It's been an amazing year, and we were kind of hugging climatology until, middle of February. So it's all this month of March. So that's the story. I mean, you get a record month of March for snow, and that puts you, if you're already at Climo, and that's about at the peak of the season, then you're going to be way above. So I don't know the last time we got 70 inches in a season. It would be too bad we can't quickly look that up, but it's probably, there's probably been a couple in the last 10 or 20 years, but not that many. So this is remarkable. And 3 of the last 4 Aprils, we've had measurable snow to the tune of 4 to 8 inches in a couple of times. So we might still get a little higher, but we certainly will tomorrow. We'll probably inch up a couple more. We'll be into 72-ish range by the end of the day tomorrow, it looks like. But I'll let Patrick talk about that. So it's been a pretty good snow season. And sometimes people will say, boy, it never seems like we really get too many big events. But we did get a few. We got this one here in February that was about 6 or 8 inches. Then we had a couple in March that were like that. We had the 8-inch on Thursday, and then the 12-inch on last Saturday. So I would say that 6-inch snowfalls here in town are relatively rare. In fact, we wrote an article about this in the paper this year at the beginning of the snow season. I think it's less than 20% of winters have a 6-inch snowfall. And how many of them have 3 such snowfalls is probably even a lot smaller than that. So this is one of those. And that's what gobbled up, some large fraction of this total 7. Well, let's go back to the satellite movie for the week, Pete. If we can just jump to the start so we don't have to wait at that would be helpful.
You want IR or water vapor?
I like the water vapor because there's a few features that we can see in it. So this starts last Friday, and it's going to go all the way to the end. So this is last week at this time. We're waiting for this wave. This is kind of the signature of some of the wave aloft. This is the other backside of it. So it's right in this region that was going to spawn the cyclone over us. And it never really had the character of really intense and widespread lower tropospheric frontogenesis. Remember with Vis-Vid, I had to kind of find the right cross-section, but you can see it was mostly mid-tropospheric frontogenesis that was in that forecast, suggesting where the band of snow was going to show up. That may still have been the case in reality, because I don't think the surface-based or lower tropospheric part of the frontogenesis was ever very strong. But it might have mimicked that forecast in reality and just moved a little to the north and west. But let's animate this and see. So this was storm number 1 that had affected us earlier in the week. Look at all the swirlies on the shear side of this big, fist of God coming down there, and then very dry stratospheric air wrapping around. This is the development of our second storm, the one for Saturday. And the center of circulation aloft is just over the nose of Iowa. Puts us right in the right spot climatologically for the heavy snow. And I think that's where this heavy snow band was, roughly from Oshkosh down to about Dubuque. And that put us in it in Madison. And it was very fine. I mean, there were places not more than 20 miles to the north and west that really did get the 1 or 2 inches of snow. And then Chicago, Rockford, Kenosha, they didn't get anything quite like what they were expecting. So we were in the perfect place. If you like snow like I do, you can't complain about that. That was pretty neat. So let's keep animating, Pete. And that storm is pretty intense, moves across southern Canada. And then here's Wednesday, that's not Wednesday morning. We had a little bit of a trace of, not a trace of snow, I guess it was a trace on Sunday. It snowed again Sunday, and for a while at my house, I thought, here's the 1/10 of an inch, but wasn't enough. And then we'll see another one come by on Wednesday. It's probably tied to this wave right here, I think. Come across. Yeah, here it comes. So this is about Wednesday, and that was Wednesday morning, and we had a little bit of snow, I don't know, between 5 and maybe 6 a.m. But again, just a trace, nothing happened. Meanwhile, beautiful swirlies off the coast of Washington State all day long there, and we'll talk about that from another view because it's part of a big anticyclonic wave break to the north. And then let's keep going. And that was our last chance for getting over the record. Well, no, it wasn't. We had a little bit of a frontal passage on Thursday morning, but there was not much with it. It was cold enough, but it didn't really snow. And then now we're into this big southwesterly flow burst. This is yesterday afternoon. Now we're in the morning today. And you can see that big wave aloft has moved on to about the Big Bend area of Texas. We'll see that in the upper level charts in a minute. Broad southwesterly flow, dew points in the 60s everywhere. In fact, we're dew point of, what is it, 47 or 48 now maybe? We'll take a look at the odds. Temperatures in the mid-50s. We haven't been in either of those places for months, really. And so this is a big change in a very short amount of time. But I would say overall, when you watch this, and I don't want to go over it again, we'll look at the West Coast one in a minute. It's a very stormy period, tempestuous period. Lots of swirlies, and then there are swirlies embedded within the swirlies on the shear lines of these big upper troughs. Not only in the the northern Atlantic, but also over in the eastern Pacific. And so you'll see some more evidence of that. There's one really low latitude upper trough. What is it doing there at the latitude of northern Baja Peninsula at this time of year, and then another one up in the Gulf of Alaska region. So it's a very tempestuous period of time, I think. You can tell just by looking. Look at all these swirlies here on the shear line. Then this one will kind of wrap up nicely. There's a whole bunch that continue around this cutoff. Watch this. 1, 2, 3 little smaller scale disturbances that all rotate and wrap up. It's like a big Fujiwara effect going on in the middle of that cutoff that's south of Greenland. And then the West Coast has one little disturbance in the northwesterly flow after another that matures into something more substantial over the Intermountain West all week long. So it's really been a good period of time. Let's go to the same kind of view, Pete, from the West Coast satellite, where things have kind of calmed down at the end of the week, but if this is the beginning of last week, here's this, where are we?
That's the very beginning.
All right, let's go. Let's go forward. You'll see some cold air upper troughs finding their way offshore over the Pacific Northwest. There's the most intense one right there. It comes off of Alaska. Look at this disturbance to the northwest of Hawaii. One after another over here near closer to the date line. So this feature just keeps on spinning around off the coast of Oregon and Washington. All the little perturbations in the shear flow are beautiful. So it's one after another. That was the one with some heavy snow and some of the Sierra. 1, 2, 3. Just, almost everywhere you look, there's lots of swirls and lots of storms at this particular time of year over this location. So that's been very interesting. It's been quite a stormy end of March. Okay, so let's now take a look in, because I think we want to focus today on what's going to happen this afternoon, tonight, and Saturday. So let's start with our observations. We'll start at the surface, I guess, so we can get an idea of what we're looking at currently over us. And currently, we are, slide over a little bit, Pete, stop in Wisconsin. Thanks. Look at this, 57 over 51, the first 50 dew point of the calendar year, I believe. I don't think we've been there yet. So we're at 51 for a dew point. It's 57 dew point at Rockford, 59 in St. Louis, so it's widely high 50s, and then further south, there's plenty of dew points in the 60s. I don't know if I see one yet in the 70s. We go further south, maybe we'll see one. Yeah, one down here near Victoria, Texas. There's one near, I don't know where that is. It's to the east of Houston. Houston itself is about 60 or 67. So a few 70s, but widespread 60s, and then a big drop off. You can see here we're in the 60s with about a 50-degree wind shift, and the temperatures are roughly the same, but dew points drop into the 30s. 10 over here to the east of Lubbock, and you've got 60, 63, 60, and then in central Oklahoma, dew points in the 20s. 40 knot wind, 72 over 22, watch out. We'll look at soundings in a minute too and see what's going on. I looked particularly at a sounding today at Topeka and then one at Norman. Those were very interesting. Surrounding places around there don't have the same characteristics. We'll take a look at those in just a second. But let's now go to the Pacific Northwest and see what's going on up there. Oh, first, I'm sorry, Pete, let's go back to Wisconsin. One other thing I wanted to mention is in our own state, we have a substantial boundary to our north. I mean, here we have all southerly flow with dew points in the mid and high 50s, and to the north from Green Bay northward and westward across to La Crosse, temperatures are in the 30s, light rain, dew points are in the low 30s, so it's an entirely different air mass to the north there. And the center of the circulation for this storm that's getting organized is right here in western Iowa. Sea level pressures around 994, 993 maybe is the lowest reported one. So it's not a really deep cyclone yet, but the circulation's fairly intense and spawning some snows already in the Dakotas. Moderate snow in a couple places in Nebraska, central South Dakota, lighter snow at Sioux Falls. So this is going to be a band of really intense snowfalls, probably a foot or more there today and tomorrow, and then again on Tuesday it looks like. So it's going to be a number of different events that will hammer the upper Midwest, both with snow in some places and then with the threat of severe in other places across the region over this week. It's going to be a tempestuous week. Okay, so I guess let's go to the upper level charts next.
Did you want to say something about the Northwest?
I didn't. I was thinking about the radar and the satellite, so I don't need to see the surface on it. So let's take a look at the radar, if we could. I wanted to do that first, Pete, sorry.
All right.
So here's the radar summary, and boy, you can see the boundary right where it is. We're just to the south of this boundary. And this is probably where you start to see, as we just saw in the temperatures, in the 30s to the north where it's raining, and everywhere down here nothing's happening yet. Notice these cells getting a little bit more widespread, not any better organized. Both of those things are scary if you ask me. All across the state of Missouri. We'll take a look at, as I said, the Topeka sounding and the Norman sounding a little bit later. And then here's the back side of this broad upper level circulation. I think we'll find at 500 millibars. That's where the snow band is right now in the Dakotas. And you can tell by just looking at these little elements showing up, it has the feel of a convective snow band. I wouldn't be surprised if there's some thunder and lightning in there. It's not linear, it's not a stratiform feature, but it's going to snow. So really, really interesting weather system developing here. There'll be a whole bunch of questions probably by people in the media. Is this a climate change thing and all that? No, I mean, you can go back in history and find these are the kinds of storms that happen in March and early April where you get severe convective threat across the lower Mississippi Valley, sometimes into the southern Great Lakes states, and heavy snow across the Dakotas and Minnesota. It's not that uncommon, but it's always noteworthy. And so one always finds it interesting. And here's some of the precipitation features I think that came through us overnight. Maybe some of these are even related, but I think it's more this. And then widespread, but not particularly well organized precipitation across the Intermountain Appalachian region from Tennessee up to western New York State. But this is the stuff that's of interest. So let's take a look first at the upper level charts from 12Z. We get an idea of what the broad complexion of the environment is in which these things are beginning to sprout. So let's take the GFS at this time. So this is 12Z Friday, 31st of March. Very sharp upper trough. We kind of saw evidence of that in the water vapor satellite movie. But we're talking about 80 knot winds at Dodge City, 80 knots at Amarillo, and fairly sizable temperature gradient. The lowest measured temperature is -30, and the analysis puts it at about -31. but where we have those strongest winds, it's in the mid-teens. So we've got, a 14, 15 degree temperature contrast across this region of really strong shear. That's a decent upper front. I'm willing to bet that this is somewhat anomalously low geopotential height for this time of year, although maybe not staggeringly so. But broadly speaking, one sees flow off the Mexican plateau into the plains ahead of an upper trough. That's a deadly combination, because the dry air off the high terrain of the Mexican plateau puts the elevated mixed layer on top of moist air, which we'll look at lower levels, coming in off the Gulf of Mexico, and then the wave itself provides the means to lift that air and realize the convective instability that we'll see evident in the sounding. So it's a perfect setup, and it's characteristic setup for this part of the world. And this is Tornado Alley, and then Dixie Alley's over here. So we've got to worry today, I think, more in Tornado Alley than in Dixie. So let's go a little lower, Pete. Let's see what it looks like at 850, and then we'll go back to 300 and see what it looks like at that level. So here's the flow of air off the Gulf of Mexico that's kind of filled in over the lower Mississippi River Valley. We saw 60-degree dew points at the surface. There are occasionally spots where the dew points at 850 are really low. The dew point depression at Baton Rouge is 21, which is kind of stunning. But everywhere else, Little Rock, it's only 1. Same at Monette, same at Lincoln. So this is a widespread region of lower tropospheric, high, abundant moisture. And then just to our north, we have a frontogenetic diffluence over this temperature contrast, and that's why that precipitation band is there, and not to the south, because we're not in the forcing region. And then the cyclone's developing over the western part of Iowa. Currently 1299 is the analyzed lowest geopotential height. The lowest observed is 1326, quote unquote observed, at Omaha. So it's a pretty intense cyclone, and that is down shear. Can we go back to 500 millibars? Just put my pointer there. See what that looks like. Yeah, that's pretty much down shear of the strongest curvature, and also there's some diffluent flow aloft confluence as well there. So it's a nice place for a cyclone to develop. Pretty decent upward vertical motion force. What about 300 millibars? Let's take a look at that. So at 300, very interesting. So here's sort of a polar jet core to our north and east, and we're sort of, I guess, broadly speaking, in the right entrance region of that, and that is, I think, favorable for ascent. We also have, we're downstream of the anicyclonic maximum in the curvature, and so the flow is super geostrophic here and kind of not so here, and so they're competing with each other. The anicyclonic curvature and the right entrance region of the jet are in competition, so I'm guessing the lower tropospheric frontogenesis is what's driving the ascent there. And we've got our cyclogenetic region back in here, and that's perfectly positioned downstream of a stubby jet exit region. Mostly the along flow speed change that's notable here. It's not that it's narrow in the across jet direction, but this is a pretty decent slowdown, so that's going to induce an agiosophy that leads to divergence here, and that's also downstream of the curvature-induced divergence. The flow is subgeostrophic here and supergeostrophic here, and so that's a perfect place to be if you want to develop a cyclone. So everything's working towards developing an intense low-level circulation with abundant baroclinicity associated with it and substantial moisture contrasts. So we have right here in the central part of the United States brewing some really interesting large-scale dynamical conditions. Let's take a look at the sounding at Topeka, and then we'll do the same at Norman. So here's Topeka from 12Z this morning. Pretty nice sounding. Here's the surface-based parcel of ascent. So temperature and dew point are nearly the same at the ground. You get to the LCL pretty low, and then you're going to be cooling along this particular moist adiabat. So we got a lot of positive area on this sounding from about, what is that, 680 millibars up to about 220. And this is very little inhibition. It's not zero, but it's little. It's not very much. And in fact, if you lift, I guess if you just start the lifting right at the top of the slightly inverted layer in terms of the dew point, you're going to follow the same moist adiabat, maybe a little bit closer to the blue line, and have, again, interference with a little bit of inhibition. Let's see. The Cape is something like 1562, and the inhibition is only 97 joules per kilogram. So with an intense circulation developing just to the northeast and northwest, and also a decent cold frontal structure, it's going to be easy to lift this through this inhibition layer. And that's a lot of positive area. It's manifested in the Cape. So pretty substantial potential for convective activity. And it looks like one of those soundings where it's nearly saturated in the boundary layer and then bone dry off. Here's the elevated mixed layer. And the other way to tell that that's partly what it is the lapse rate's nearly dry adiabatic. You've been baking this air on the Mexican plateau for a couple of days and it's finally been infected out over the plains. It's a deep, well-mixed layer. So the lapse rate here is maybe 8.5 degrees or something like that. It's pretty good. Almost dry adiabatic and bone dry. So the convective potential is substantial. Let's take a look at Norman. And at Norman, one gets roughly the same picture with even less inhibition. So again, if you were to, it's better to lift the air starting at about this level, 900-ish millibars, because that's the one that's going to be right along the same as the surface-based cape. And you only have this little bit of inhibition. What is it? It's 6 joules per kilogram compared to 2174 for the cape. So the positive area is huge. There's not going to be any problem getting through that inhibition in this case. And notice that at this far this is interesting, this far to the north and west, it's not as dramatic a drying for the elevated mixed layer, even though the lapse rate and the level at which it seems to exist is about the same as we saw on the Topeka side. So that's just about a dry adiabatic lapse rate, indicative of the elevated mixed layer. But it's not as dry for some reason. Maybe historic precipitation into it or something has moistened it somewhat. It gets really dry at 500, but something's happened underneath that. But these are about the only 2 soundings. You can pick apart all of them in the region. These are the only 2 with substantial, at 12Z, with substantial cape. But if we go to tropical, we can take a look at they do an analysis of the most unstable cape, and most of the times on this particular day, those are all surface-based, as it turns out. So I think they do it here. Is that right, or am I thinking of the wrong place? No, it's pivotal, because they have severe weather diagnostics.
That was a fail.
Pivotal, of crucial importance in relation to the development or success of something else. It's a good definition. It's a real skill to write a good definition. Let's go to models. And then it's at the bottom of all of this, severe weather's at the bottom, so. And then most unstable cases is pretty good. So here's what it looks like at 12Z from the beginning of the simulation. And so Topeka's in that region, Norman's here, and so you can see this is a narrow swath of really decent, most unstable cape. And I think the orange is something in the 1200 range or something that's down underneath this advertisement. Oh, 2000 range, okay. And then click maybe one time ahead. I don't want to steal Patrick's thunder, no pun intended. Gets even narrower. Isn't that awesome? And that's right ahead of where this sizable temperature contrast is. I don't know whether it's frontogenetical. I don't think that it is particularly, but you're talking about nearly 2,700 joules per kilogram of cape. That's pretty good. And then maybe one more. That'll get us to right about now. Yeah, it's just a narrow line, and so we're beginning to see those cells erupt in central Missouri, and it must be in response to this combined with the forcing. Remember, the upper trough is configured in such a way that the development is going on here. So the most intense synoptic scale updrafts are going on here, but they may well be frontal scale updrafts that trail along that baroclinic zone. So that's kind of what we could do. One more thing here, I think maybe they have the frontogenesis at 850 or something like that, do they? Right there. Let's see what that looks like at the same time. Yeah, see, it's only along the warm front. So here's the baroclinic zone up there in eastern Kansas, northwestern Missouri, and this was the thin strip of greatest cape. One doesn't see, at least at the contour threshold, any particularly strong frontogenesis. But remember, we had very weak inhibition in those 2 soundings. We also do have a notable temperature contrast, and there's a wind speed difference across there. So even though it doesn't reach this threshold where it's more enticing to consider it as a really serious forcing, it's probably not 0. And in fact, it's definitely not 0. Some of these places in Missouri that have lit up in the last hour have little spots of positive frontogenesis there in the right spot. And so that's all you need to get that air rising. Force it to rise, then stand back. If it's got all that cape, it'll just do it on its own. Okay, so that's the setup for what we're looking at. This is all potentially gonna fill in during the day. I mean, we can go to the HPC or SPC, what is it? SPC, yeah. We had that chart up. We'll get the most recent one. It's different from what I saw earlier this morning. And so here you go. You can already see, even in Arkansas, some of this linear structure, which is right about in parallel with the moderate and a couple of pockets of high risk. The high risk is probably closely aligned with the synoptic scale ascent. I'm not sure what's going on here. This might be just a local place where it's going to blow up, perhaps due to some other type of forcing. But we are not far off from a really substantial risk for severe weather here, and so it's going to be kind of one of those days where you're looking and wondering, and that's only today, as it turns out. So, Patrick, I'll let you say something about the actual details of the forecast rather than the broad picture. Thank you, Pete.
Thanks, John.
We can stay on this. Can we go back just one more? I know that I'm young. I don't think I've ever seen a particularly dangerous situation. So this is really intense wording for a tornado watch from Minnesota all the way down to Arkansas.
Yeah.
That is pretty incredible to see states worth of these tornado watches, which are reserved for the highest classification. Let's just click on like Iowa, Illinois. So, I mean, there's high probabilities of very strong tornadoes in this large region, and this extends all the way down to Arkansas. So it's a very incredible event that's happening right now. Very well forecast if this pans out, but very strong warning. Potential for strong to violent tornadoes, and this extends states. So this will be something to watch, and I'll point out maybe some details of this, and then also go back to there's still more snowfall for the Pacific Northwest. So if we could go back to just weather.gov on this page, please, Pete. So here, and then scroll down, we'll just start at this. This is a look at the hazards for one single low pressure system, extending from the Rocky Mountains all the way to the Atlantic coast. This is all the same event. We have this large expanse of tornado warnings, we have blizzard warnings, winter storm warnings, feet of snow right next to where you have very strong potential for tornadoes, incredibly bone dry region where you're in a drought currently. You have a very strong low pressure system developing, very strong winds, low relative humidity, very strong fire potential, right next to where you have tornado watches, and then these like brown colors are all wind advisories. So this is a very impactful event for the entire country, essentially. And this will move and track towards the Northeast. So even the Northeast will get in on the action for this single event, which is pretty remarkable. These are some of the coolest events, in my opinion.
Yeah.
When you have blizzard warnings next to tornado watches, it's just miraculous that that can happen, counties away from each other. So let's scroll down here and go to the Outlook maps, please, Pete. And we'll look at the QPF. Keep going. Right there, current Outlook maps. And then if we could go to QPF. So this is the quantitative precipitation forecast, or the amount of liquid precip expected. Looking at day one, so this is today, into tomorrow morning, we can see, you can kind of make out the low pressure center. So it might be located somewhere in Iowa, Nebraska, and you can see an clockwise rotation of all of this precipitation around that low pressure, even maybe individual storm tracks, which is, these most likely won't pan out, but it's pretty cool to see that there are this fine detail of where these storms might track and rain out. And a lot of where we see the bullseye of precipitation, liquid precipitation, this is all going to be snow. So this might be 2 feet plus of snow just to our north, where we're getting severe weather.
Wow.
So we're missing out on the heavy snow, which is okay in my opinion. We already got our fair share of snow. And we're into more of the spring-like weather, but northern Wisconsin is still going to get pummeled with snow, and into the Twin Cities as well. And then if you notice, there's still precipitation out west. This has seemingly happened every single day, I don't know, for a couple months. And we'll go to day 2, we'll just look at how this progresses. So you can see the low pressure moves off to the northeast. You can still kind of make out the clockwise rotation. in precipitation. Still raining and snowing over the northwest. Then let's go to day 3. We see maybe some evidence of this might be a stationary front or just a moisture boundary, but still raining and snowing over the northwest. We'll go to day 4. Still raining and snowing over the northwest. Here's our second snow and rain event that's beginning to develop. We'll go to day 5, and that'll be the last time I'll show. We can see, again, clockwise rotation and all this precipitation, or counterclockwise, sorry, where this is another band of heavy snow to our north. We're probably in the liquid precipitation, but again, another potential severe weather risk. And this has actually been noted by SPC already, that there may be severe weather to our south again, looking like the same regions as today. So 2 main areas right over us in the central United States, and then into the Pacific Northwest. So if we could pull up the AOS page, the NAM forecast model, please. And let's see. Yeah, I think I looked at the 12 UTC 211 one. And then yes, let's do this loop first. And we can stop it and go to the beginning. In here, and let's go 1 click forward so we're at the current time, or about. So this is a look at the current guess for the NAM model. We see our low pressure center almost exactly where it was in the surface obs, so that's a good verification. We can see that heavy snow over South Dakota and into northern Nebraska. Storms beginning to fire up where they pretty much are. So this is really good verification, and you can notice no storms, presumably no clouds, and this was verified on the satellite. This is where some of the highest tornado potential is right now, and that's a bad look. That's a lot of energy going into these storms. So if we step forward one more time.
Can we go back 1 moment?
Yep.
We saw in another forecast panel that at 850 millibars, there's not much of a temperature contrast from Missouri draping down into central Texas, but look at the thickness contrast.
Yeah.
So it makes you
right.
think that there's, just like last week for the snow, there's a mid-level baroclinic zone that's frontogenetically active, and that may be why it's not frontogenetically active at 850, but that's not the thing to look at, so.
Right.
And SPC doesn't, of course, really bother itself with saying what's forcing the air to rise. They just expect it'll convect, I guess.
Right.
There's got to be some reason why it's linear, and it's it's probably a mid-tropospheric frontogenetic band. That's really interesting.
Yeah. And you can even pick out where the warm front would be sitting, and this is almost exactly where it was, just gradient and thickness.
It's a really obvious structure to the north. It's a little bit more hidden in terms of where's the frontal structure to the south of the cyclone, because it's at the mid-levels, it's not at the ground.
Right, that's right. So let's step ahead 1 time, Pete, please. We can notice the low tracks over eastern Iowa. Now we see a deepening of 6 millibars in 6 hours, so that's something I'll touch on. Why did this deepen so rapidly? But this is a bad look. If you like severe weather, this is good. You'll see stronger forcing, stronger low-level winds, coupled with an upper-level vortex. This might be a big event, in eastern Iowa and into our region. I'm not too convinced that we're out of the highest potential for severe weather, even though the SPC has us kind of on the border. It looks like if we step 1 more time, Pete, please. We kind of get slammed with whatever develops in eastern Iowa. Very heavy precipitation. These are 6-hour precip, over 1 inch, and this is all snow into northern Wisconsin and central Wisconsin, and then into the Twin Cities area. And we'll step 1 more time, please. We can see a band of heavy snow sets up just to our north, and this might be wraparound snow. So we might get some flurries, but it's not looking like too strong potential, not like north central Wisconsin and into the UP of Michigan. And so let's go back to this same page. We'll go back to 18 hours on this one, Pete. Sorry, on the loop. We'll go back to 18 UCC today. There we go. Okay, so I want to point out, first, this is a look at currently. I'll put my cursor where the thermal wind is located. So it's blowing with parallel to thickness with cold air to its left. So it's something like this. Could we go to the 500 millibar map? We'll go to 18 UTC again. Perfect. So if you notice, this might be a little off, but the thermal wind is advecting all of this vorticity at the base of that trough straight where the low pressure was located in western Iowa. So that's a very strong signal for deepening, and that's what happened on the surface maps. We got 6 millibars in 6 hours, and that's directly tied to this strip of high vorticity well to the south of where the actual low is centered. And if we go one more time, we can notice it becomes more diffuse after this time. This is when the low is over eastern Iowa. We lost, starting at this time and going on further, we lost that strong deepening and rapid strength in this storm. So there's about a 6-hour window where this low that's over western Iowa will track into eastern Iowa, strengthen, and then begin to weaken. And that's the highest potential for the severe weather in our region. And then we go one more step forward. We can notice then, can think that all of this vorticity would be advected to the north by the thermal wind, and then you have a strong band of snow that sets up just to the north of where this upper level vortex is located, and very cold air associated with this, these lower heights as well. And we'll verify this. Let's go to 850 on this same map, please. We'll go back to the beginning. Perfect. So this is a current look at the current time. The front at 850 is almost exactly where it was analyzed. And if we step one more time forward, we can see we almost have exactly southerly flow straight to the north over our region and over northern Wisconsin. And this is where you would get all of this warm air rising up over more statically stable air. This is where your heavy snow is going to be located. And that's
Yeah, and look at the wind shift. I mean,
Right.
on the shore, on the border there, Ironwood, Michigan, you've got easterly winds and you've got southerly winds at Baraboo. So an
That's right.
incredible frontogenetic band there.
and it goes from like positive 6C to negative 6C
Yeah.
across that
Awesome.
narrow region. And let's step ahead one more time, please, again. And we can see that time is probably the best if you want a very strong baroclinic zone and heavy snows, and then you kind of lose that strong southerly flow. It's not as intense as it was right over our region. So very narrow window for a strong band of snow to set up. And then if we go one more time, like was forecast, we kind of lose all of that forcing, and the low becomes weaker and just moves off towards the northeast. And you can see all of this wraparound cold air extending well to the south, well into southern Missouri. So this might be our flurry potential with all of these colder 850 temps.
Too late.
Too late. About 6 hours too late. Just missed it.
Man.
So now, I think the next thing I want to show, let's go to this, excuse me, Sierra snow plot.
Before we get away from the severe weather,
Oh,
I
yeah.
just want to say, Tom Whitaker's watching online. He said Iowa City Public Schools are closing at 2 p.m. today
Oh, really?
because of the severe risk.
Wow.
That's smart.
Does that happen often? I've never even heard of that before.
I know the Nashville Sounds have postponed their opening day game. They're going to have a doubleheader tomorrow.
Oh, yeah?
Because
Okay.
of severe weather.
Wow.
That sounds reasonable.
Yeah, that's a very smart choice. Especially, it looks like it's maximized right near Iowa City. That's where I would expect the
It's
biggest
happened
storms.
before. Schools where I'm from are out at noon today.
Oh, is that right?
Oh, yeah?
Wow.
Wow.
So, a lot of students
Never heard of that.
in this region are getting out of school. Let's go to the snow map. So switching gears now. Oops, not that one.
Sorry.
That's okay. This one here. So this is a screenshot of a tweet I saw. California officially has its largest snowpack in recorded history.
Wow.
The statewide snowpack is 236% of the peak normal. And there are regions that are almost triple the normal down here in the southern Sierra Mountains. So it's been an incredibly snowy event and snowy year for California, and this extends well up into Oregon and Washington. Yeah.
Yeah, I heard that the ski resorts are gonna stay open till June this year because of all the snow they got.
I can believe that.
California.
I can believe that. Speaking of, let's go to the next.
Utah, too.
This is a house in California, Mammoth Lakes. This is a snow bank. Reaching all the way up, this is the height of the house. That's how far this is reaching. I looked up the average height of a house. It's about 20 feet for a 2-story house like this. So this is 20 feet of snow just sitting on the ground. If you were to then convert this to snow water equivalents, assuming a 10-to-1 ratio, this is about 24 inches of liquid precipitation just sitting on the ground. There are some regions in California, if we can pull this up actually. Let's go to the plus. And then it's like NR.
Did that height
Oh, there.
include drift,
Go one
Patrick?
back. I don't think that was a drift.
Go one.
There we go. NRCS, the USDA snowpack. We can go back to that.
No, it's fine.
Let's go to the interactive map. And we'll pull up basin conditions here. And then could we click on the percent of the average right there? And then we'll zoom in here. So this is showing the percent of normal for this date that the snow water equivalence is in these basins, so larger regions. Everywhere in this blue, this darker blue, is 200%. If we zoom in a little more, Pete, please. You can see some regions are 300% of normal. Let's click on this location right here, which is where that picture was taken. We'll enlarge this. So what this is showing is this is what the normal snow water equivalent should be for this day. This is where it is.
Wow.
These are this was the 90th percentile plot for snow water equivalents. So these are record by the axis on the left is how large this is. This is 70 plus inches of snow water equivalents just sitting on the ground, ready to melt. And that is verified by that. If we go back to the house picture. This one. This is verified by pictures like this, where you just have all the snow sitting on the ground. This doesn't look like a drift to me. It looks like it was just heavy snow that piled up next to in between the tree and the house. Could have been that, yeah. But, I mean, this is 24 inches of snow water equivalent, so triple that. And that's what some of these places have, based on this far plot right here. And these are, it's been record snow water equivalents since January 1st. Never before seen.
Happy New Year.
Yeah, Happy New Year. You get feet of snow every single day for 3 months. And we can go back and we'll just click, we can go back to the interactive map. We'll click on one more just to show that this is not just in this region of the world. Let's click on let's do one of these ones. Yeah, that's good. And then we'll enlarge the map as well. So again, these are record snow water equivalents.
Old Truckee, this is near the Donapati spot.
Right. I mean, all of this has to melt eventually. So even though California needed liquid rain, liquid precipitation, this is going to be too much. So there's going to expect to be, landslides and flooding for months, because you can imagine melting 70 inches of water that's all frozen is going to take a while.
Or get a cool spring, that's the only way out, right?
That's right.
Yeah.
Is to have a relatively cool spring. And
That's
then,
right.
yeah,
So it
distribute
doesn't
it in
melt
a-
as-
right.
Otherwise,
all at
it's
once.
a bomb.
I know, I
Yep.
hope that's the case, jeez, wow.
And then if some of these storms turn into liquid precipitation, you can imagine, 70 inches of snow, suddenly you're raining on top of it, on people's houses.
Yeah, and the structural damage will be
Yeah.
enormous, because that doesn't sink through there, it just weighs on it.
Right.
It's huge.
Now, some of the water that will melt first fills up the reservoirs, which have been very low
That's right.
on the eastern Sierras. But then, everything beyond that goes right down into Sacramento and on to the Pacific Ocean. And
Yeah.
that has caused some big problems about 25 years ago of huge meltwater.
Right.
And I think it'll be worse just because of climate warming.
Right, exactly.
Yeah.
And the regions of California have had liquid precipitation. It hasn't just been snow everywhere in the upper elevation. So the ground is already saturated too. So that is a pretty bad combination. And you can play around and click on this map and look at these, but a lot of these locations are record snow water equivalents for 1/3 of the United States, which is pretty remarkable to see. So,
How much of this ends up in the Colorado River Basin? Is there any on the eastern side of Colorado River?
Yeah, good point.
it should be somewhere in the below all this blue. Oh yeah,
Well, these are all drawn as watersheds probably, right?
I think so.
Yeah.
I think that's how they're done. So a lot of this will probably go
Here's
into
Lake
the,
Mead, or Lake Tahoe, I'm sorry.
that's Lake Tahoe, yeah. I know you can, there's somewhere you can decrease the opacity here.
You can see Colorado.
Well, of course, the Colorado River is bone dry by the time it reaches Mexico now.
Yeah.
Right.
It may not be the case.
Probably not the case, yeah.
Everybody wants a gallon.
Right.
Wow. Incredible.
Oh, there we go. It's a Grand Canyon, let's see.
Yeah, southern Utah's good too.
Yeah. So this is also record snow water equivalents too, or very near record snow water equivalents. So definitely something to watch.
Yeah.
Yeah.
You previously mentioned ski resorts are going to stay open through June. Is this going to have any effect on, is this going to diminish the Western fire season anyway, just this massive amount of liquid?
It's a good question. Most likely. I can't speak on how this might play out because even though there's a lot of precipitation right now sitting on the ground, there are some regions that are still in drought in California and into like Colorado. So I guess it just plays out how quickly this melts and how quickly it goes away into the summer months where you expect more dry, relatively dry conditions than what's been happening here. But most likely, it would diminish it. Yeah. Yeah.
So you mentioned she was in constant power outage in Monterey. So I guess this was growing up not just in these record-setting regions, but also in coastal region. They also have a lot of atmospheric events in the states.
Right. That's right. Yeah, all of the snow that's fallen over here has been liquid precipitation for much of the coastal California region.
Yeah.
Yeah. Any other comments or questions? Okay.
Going back to the Wisconsin storm, or like the Midwest storm, what can we expect in Madison to see? Like, not to go storm chasing, but the building has a good view on the west side.
I see. Let's go to Pivotal actually. We can pull that up real quick. And let's zoom in to our region here. Perfect. And then let's go to surface precipitation. And then I think it's at the bottom, precipitation type right here. So what's been the trend, and this is the GFS, the resolution's not the best, but, so this is a look at current. Let's step ahead 3 hours just to 9 UTC. We kind of get this spotty precipitation before the main line that's beginning to develop. That's been a pretty good signal from Iowa straight south. And if we watch this develop, let's go to 12 UTC now. We can see this line begins to develop and it sort of fills in, and this is clear on more of the convective nowing models, but it looks like a mainly severe wind threat for our region. We can even pull up, if we go to the model, let's pull up the NAM 3K. This is my preferred model. So let's go back go back to 9 UTC, please. So we can start to see this is the main line that's expected to develop. Anything out ahead of it would be more tornado potential. And we can step forward here. We'll go to 12. You can sort of see it fills in and stays pretty prevalent. There's a few spotty showers and storms out ahead of it. And then about like, what is this? So this is about 6 p.m. Let's go to 14, actually, is when it's expected to hit us. So about 8 p.m., probably right when the sun's going down, we'll get the heaviest. And it looks just like a severe squall line for us.
Yeah.
But it's already bowing out by the time it gets to us. So.
Right, that's right. So it might hold together. We might get pretty strong severe winds, but we are on the northern side of this low from this model, so this might just be heavy precipitation, no severe weather threat. It'll definitely be something. We're right on the border of where it could be really strong or it could be nothing. which is typical, I feel like, for Madison, but, yeah. And then you can see some of the wraparound snow.
Yeah, let's go to 16 hours. Yeah, forget it. No chance. We got only 1 hour to go, right? 17Z would be.
Yeah, this is midnight,
Yeah,
so all of the snow is well to our
we're not
north
gonna
and
do it.
west.
It's too bad.
Any other questions? Comments? Perfect, well, that's all I have.
Thank you, Patrick. Thanks a lot. Thank you, Pete. Everybody be careful, and you all fools in Iowa, be especially careful if they're listening.
Said the building was at 60 degrees, so first 60 degrees of the year for us.
Hey, all right.
62 is what it was. Yeah,
Very
You
nice.
could see blue sky out there too. Rooftop cameras are showing blue sky.
which is bad. It's a bad sign.
Yeah, that's true. Don't need any more jewels at the boundary layer. All right, thanks. See you all next week. Probably we'll hear from our friends in the field at that time, which will be fun. That's if they find anything interesting. I mean, it's possible it could just be a bust. It could be in Iowa.
That's true.
I mean, it's a double whammy, isn't it, to drive to Iowa when nothing happens? No one should drive to Iowa expecting anything to happen.
It's happened before.
I know. It sure has. All right. Thanks, Pete.
You're welcome. Thank
Yeah,
you
thanks,
guys.
Steve.
Yep.
Yeah.